Hey, welcome to today's lesson on solving a quadratic by completing a square. So the first thing that I want to go through is, I don't know how long this is going to take. I'm going to try to be thorough and explain it in a way that will make sense. So I'm going to break it down for you, you know, as much as I can. And then we're going to do 3 more examples. So I'm going to do it the same way that I did factoring. So on one side of the page, we'll have all the steps. And then on the other side, we'll have us going through the steps with an example. And then after that, we'll just go through a problem by completing the square without writing down all of the steps. So it's a little bit more fluid. So it might be a little bit easier for you to follow along. And then if you think you get it by example 2, I just want you to check in with example 3 and 4, because 3 is going to go through completing the square when the leading coefficient isn't a 1. And then example 4 will talk about what is it going to look like, or what would your answer look like if there's no solution or no real roots, right? So that's what this means. It means that there's no real roots, they're imaginary. So that's when you have your parabola that doesn't cross the x-axis. So if it's like kind of hovering above, or if it's opening downward and it's hovering below that x-axis, those have what's called imaginary roots. And you will be going over that in algebra 2. So I just want you to check in with example 4 so you can see what that looks like, because sometimes we're going to get those answers. So hang in there. I want you to take a deep breath. We're going to do it one step at a time. Please try not to get overwhelmed. We're gonna get you there, okay? So I'm going to turn on my projector. Open up to your table of contents. We're going to update that. So what we're adding in today is solving by completing the square. I think that's going to take us 3 pages. I don't know what pages you guys are on, but that's my page 76, and I'm assuming I'm going to go through page 79. So once your table of contents are updated, if you could turn to your page 76, title it. Gosh, I hate that this is backwards for me. And before we get into really going through and solving it, I just want you to understand what completing the square means. Completing the square means you're going to have a perfect square as a binomial, right? So 49, we know the number 49 is a perfect square. And so a perfect square would be, for example, like if you had x plus 4 quantity squared. This is a perfect square because what that means is x plus 4 times x plus 4. So it's the same factor multiplied by itself, okay? So just like we said, 49 is a perfect square because that is 7 squared, right? X plus 4 quantity squared is a perfect square binomial because when you expand it out, you get the 2 factors that are exactly the same. So I just want you to keep in mind that this is what we're talking about when we're completing the square. We want a perfect binomial square, okay? That's our goal. And I am going to show you how to do that. So on one side of our paper, we're going to have the step, and then we'll have the example. And you know me, I'm not the best at writing things in words, right? And I really miss having you guys around so I can figure out the wording better. But I will try my best. So the first thing is is you want your leading coefficient, which is your A term. You need that to be a 1. So your leading coefficient must be 1. If it's not, so that would look like just x squared by itself. Okay? So if not, you need to divide each term by A. Okay? So if it's not x squared, say it's 3x squared, then you would have to divide every term by 3 if it were 3x squared, but because you want it to look like just x squared. Okay? So if we had the example, let's do 3x squared minus 6x minus 24. I wrote 18, and that should say 24 equals 0. So our A term right here is not a 1. So I need to divide every term by 3. And if there's anything on the other side, you have to do the same thing there as well. So if the 24 was over here, you would have to divide 24 by 3. Okay? So what we're left with is x squared minus 2x minus 8 equals 0. Okay? So not too bad, right? Okay, step 2 is to make sure that your variables, which is the ax squared plus bx, variables on one side of the equation, and the constant, which is your c term, on the other. So you want that to look like ax squared plus bx equals c. That's what you want to do, okay? So I have my x squared minus 2x minus 8 equals 0. Great. My leading coefficient is now a 1, so that's perfect. So now I want to move my constant term, that negative 8, I want to move it over. So I'm just going to add 8 to both sides. So now I have x squared minus 2x equals 8. Okay? So what I tell my students, and in my next examples I'll show you, I don't do it as a separate step, but when we move the c term over, I'm just going to move this down. I usually tell them to do plus blank equals 8, because this is the step that is going to help us complete the square. And I'm going to show you how to get that number in the next step. So when I'm usually going through this, I tell my students just to leave a little blank there so that they don't forget this part of the step. Okay? So far, we made sure our leading coefficient was a 1. So I divided every term by 3 to get that to happen. The next step was I wanted all my variables on one side and my constant on the other side. So all I did was add 8. And then when we move that over, I usually just tell my students to do plus blank and leave a little space there. And you'll see why next. All right, so now we're going to get into completing the square. So step 3 is divide the b term by 2 right? So that's taking b, dividing it by 2. And what I tell my students to do here is to write that number down here. So make a little note to yourself, right? So -2 divided by 2 is -1. All right, so I'm telling you, this is where it's going to get confusing. You're going to go, what are you doing? Stick with me, okay? So divide the b term by 2, and I write it here. After you do that, you need to square it. So -1 squared is 2. No, Greenway, it's not 2. -1 squared is 1. So we're going to square it and add it to both sides. That's why we have the blank here. So I take half of my b term. I just make a little note down here. Half of b is half of -2 is -1. I square -1. -1 times -1 is +1, and I add it to both sides. Okay? So I'm going to do a little side note to show you what's leading into what I fill in here. Okay? So you do not have to write this down. This is just showing you what we have. So I'm going to go off of my notebook for a second. So we have what we just did. We did x squared minus 2x plus 1 equals 8 plus 1, which is 9. Okay? If I were to factor this trinomial, right, forgetting about the 9, I just want to factor this right here. You can go through your factor thing, right? So a times c is 1 because 1 times 1 is 1, and b is -2. So what are my factors of 1 that when added together give you -2? Well, since 2 is negative, I know both of my factor terms need to be a -1. So -1 times -1 is +1, and -1 times -1 is plus, -1 plus -1 is -2. So that is what I write there. Okay? So I'm just factoring this trinomial the way that we learned last class. And I'm showing you why in a second. So now I'm going to take x squared minus 1x minus 1x plus 1, and that's equal to 9, right? Because it's not 0 anymore. So then I can do my parentheses. That's a negative, so that becomes negative. So now I factor out x, right? And I'm left with x minus 1. My minus, I'm going to factor out a 1, x minus 1, and that equals 9. Okay? So my two factors, my two binomials are x minus 1, right here, and then x minus 1. They are the same thing. So therefore, I can write it as x minus 1 quantity squared equals 9. So instead of going through this whole process here with completing the square, I teach my students a shortcut. And this is why the shortcut works. Okay? So back to our notes. See how we wrote half of b? Yes, Mrs. Greenway, we see that. I'm basically talking to myself and trying to organize myself right now. What you then do is you complete, I don't know how to word this. This is why I wish you guys were here. Complete that perfect square. And I'll show you how to do that. So remember, right, we had x minus 1 quantity squared equals 9. And over here, we wrote half of b, which was -1, and I told you just to write that underneath it. So then we just do this. X minus 1 quantity squared, equals, and then 8 plus 1 is 9. So we have the same thing, right? X minus 1 squared equals 9. Here's my shortcut. Write down half of b, which was negative 1, right? And then we squared negative 1 plus 1. We added it to the other side, plus 1. So step 4 is to complete that perfect square by doing the shortcut. So we just do all the time, because when you complete the square, it will come out perfectly, a perfect square, because we just did it, right? So quantity, x minus 1 squared, equals this side simplified, which is 9. Okay? So this is the hardest part for students to understand about completing the square, especially when you're dealing with fractions, because right now we have nice, easy numbers to work with. So step 4, complete the perfect square, which is adding in the x, the parentheses, the square, equals, and you simplify the term over here, okay? Step 5, we are going to solve. So we have x, I'm going to rewrite it, okay? So I'm just going to rewrite it down here so I can show you. So we have x minus 1 quantity squared equals 9. So if you were to have, this is again, don't write it down. What if you had x squared equals 49? Well, you know, right, that x times x is 49, so 7 times 7 is 49. You know that, right? And a long time ago, I asked you to keep in the back of your head that squares or roots, there's always 2 roots, right? So if I take the square root of x squared, that gives me x. The square root of 49 is 7, and it's also negative 7, right? So we can write that as plus or minus 7, okay? So we're going to solve this in the same way. So to undo a square, I take the square root, okay? So when I take the square root of x minus 1 squared, I just have x minus 1 equals the square root of 9 is plus or minus 3, right? Positive 3 or negative 3, okay? So you're saying to yourself, okay, Mrs. Greenway, when we factored, we got 2 answers. You're right, we did. So I need 2 answers here as well. And sometimes you will get 1 answer, but not any of these cases, okay? So now I can do x minus 1 equals positive 3, and then x minus 1 equals negative 3. So that's to take into account the 2 roots of 9, which was positive 3 and negative 3. Okay, so then I just add 1, and I get x is equal to 4. And then add 1, and I get x is equal to negative 2. So the way that you can write your solutions for quadratics, and I don't have a preference. Your algebra, or I'm sorry, your geometry or algebra 2 teacher might. So just go with what they want. But you can write it as a solution set like this, which is like negative 2 and 4. Or you can just leave it as x equals 4 and x equals negative 2. This is just a solution set. They're literally squiggly lines. It's not that fancy bracket. Okay? So that's how you complete the square. And if you were to factor this out, we would get negative 2 and 4 for an answer. All right? So I am now going to do another example. without pausing and breaking it up into so many different parts. And before I do that, I'm going to take my middle section of my notebook out. Okay, maybe I'm not going to do that because it's really hard to do. Okay, Greenway, refocus. I'm just going to have to deal with writing on this weird cardboard here. All right, so I know I'm weird. I can't help it. Let's do example 2. So we're going to solve by completing the square. And our quadratic is x squared plus 6x plus 3 equals 0. All right. So step 1, make sure your leading coefficient is a 1. It is. Perfect. We don't have to do anything for step 1. Step 2, you want your A and B terms on one side and your C term on the other side. So I'm going to subtract a 3 from both sides. So now I have x squared plus 6x plus blank equals -3. Okay? So that's steps 1 and 2. Step 3, what color did I use 3? Blue. Step 3, divide the B term in half. Half of 6 is 3. So plus 3, right? This is just for later. So half of 6 is 3. I square 3. 3 times 3 is 9. And add it to both sides. Okay? Took half of B, which is 6. Half of 6 is 3. I square 3, which is 9. And I add it to both sides. Because now this is a perfect square. Because I just made it. And whatever I do to one side of an equation, I have to do to the other side of the equation. Okay? So that's why I do that. So now I'm up to step 4, where I do my shortcut. So I know I made that perfect binomial square right there. So I just do parentheses x squared. And that equals -3 plus 9 is 6. Okay? So now I have a perfect binomial as a perfect square, and I simplified over here. So now I can solve it. And I solve it by taking the square root of both sides. So the square root of x plus 3 quantity squared, the square root of a square cancels out. So you're left with x plus 3 equals the square root of 6. Now, we do not round. Okay? You leave them as exact answers. So leave as exact answers. That is until we graph, but that's okay. Because when you're graphing that, you're not going to know where to plot up the square root of 6 anyway. So we can estimate. So the square root of 6 is plus or minus radical 6. Your radicals! Oh my gosh, remember when we did this all the way back in September? Yay, here they are. And yes, you want them to be the most simplified version that they can be. So that's why we spent a lot of time rationalizing or simplifying radicals. So radical 6 is as simple as that gets. So now I can break that up into 2 terms. So I have x plus 3 equals positive rad 6. And then x plus 3 equals negative radical 6. And then I just keep solving. So I'm going to subtract 3, So I get x is equal to -3 plus radical 6. Yes, that's how you leave the answer. And then I subtract 3 from over here, and I get x is equal to -3 minus radical 6. And those are the solutions to that quadratic. So do you see how we can't factor? There's no way we would be able to factor out and get -3 plus radical 6. So this quadratic would not be factorable. And then you'd have to say, oh, well, I have to complete the square if you were told you could solve it however you wanted. Okay? All right, so hopefully this is making a little bit of sense. And of course, as usual, I'm going to throw a monkey wrench in there. So example 3, let's do 4x squared minus 2x minus 5 equals 0. So back in our first example, our leading coefficient was not a 1. However, every other term was a multiple of that leading coefficient. For example 3, unfortunately, B and C are not multiples of 4. So we are going to be working with fractions. So I need to divide every term by 4. So I get x squared minus 2/4 x is 1/2. So 1/2 x minus 5/4, and 0 divided by 4 is 0. Fun! I know. I can hear Hannah saying that out loud as she's watching this video, going, fun. All right, so that was step 1. So now step 2 is to move my C term over to the other side. I'm going to add 5/4 to both sides. So I have x squared minus 1/2 x plus blank equals 5/4. Okay. So now in step 3, I take half of 1/2. Half of a half is, or it's -1/2. Half of -1/2 is -1/4. So I write that down, -1/4, because that's half of 1/2. Now I have to square -1/4. So 1 squared is 1, 4 squared is 16. So plus 1/16, add 1/16. Okay. So now I do my little cheat method so I don't have to factor that out because I wouldn't want to. So I just do my parentheses, x squared equals, so 5/4 plus 1/16. Well, 5/4, I need a common denominator, so I need that to be 16. So I multiplied by 4, so 5 times 4 is 20. So this would be 20 over 16 plus 1 over 16 is 21/16. So you remember when I told you had to be really good at fractions? I wasn't kidding. Alrighty, and now step, what are we on? 5 is to solve. So I take the square root of both sides. So the square root of a square cancels out. So I have x minus 1/4 equals plus or minus. So remember, that's like radical 21 over radical 16, and radical 16 is a perfect square. So that's plus or minus radical 21 over 4. Alrighty. So now I can break that up into two equations. So x minus 1/4 equals radical 21 over 4. And x minus 1/4 equals negative radical 21 over 4. So then I add 1/4 to both sides. So I get x is equal to 1/4 plus radical 21 over 4. I can write as 1 plus rad 21 over 4, right? Because they're common denominators. So I just add the numerators. And then plus 1/4 here, plus 1/4 here. So I get x is equal to 1 minus radical 21 over 4. And those are my answers. And remember, that means this is where your graph crosses the x-axis. Okay. So that's probably one of the toughest ones that you could encounter because it deals with fractions. Okay. So you need to be good at simplifying radicals, and you need to be good at working with fractions. So both things that I have been stating, well, definitely the fraction piece I've been saying all year. And then when we were doing radicals, I said we needed to be pretty good at them, and this is why. Okay. So example 4. I already told you this was going to be a special solution. So let's look to see what it looks like. So if we had x squared plus 2x plus 20 equals 0. All right, so now I'm going to subtract 20 from both sides. So I have x squared plus 2x plus blank equals negative 20. That one should have been done in pink. Sorry. So now I take half of b, so half of 2 is 1. I square 1, which is 1, and add it to both sides. Okay, so then I finish my perfect square. So x plus 1 quantity squared equals negative 20 plus 1 is negative 19. So you're like, okay, cool. Let's go to solve it. So when you take the square root of both sides, right, you're left with x plus 1 equals plus or minus radical negative 19. Well, the square root of negative 19 is not a real number, right? Because it's negative. So a number times itself can not give you a negative number. So this is no real root. Or we could say no solution. Either way, right? If it's asking you for what are the roots and you go through and you solve it and you get this, you would say no real roots. If it tells you to solve and you go through this, you would say no solution. All right. So those are the examples that I have. And of course, I thought this was going to take more pages in my notes than it did, but it didn't. So I'm going to go through a couple more examples in the second video. So if you want to see more examples and have me talk through more, then hop on over to that video. If not, you can try the examples on your own, see how you do, check your answers. And if you get them right, move on and do your Flipgrid. So the Flipgrid is really the only way that I can check to make sure that you fully understand how to go through the steps for completing the square before moving on. So that's why the Flipgrid is easier for me, because in Edge Elastic, you could solve it by factoring. or Google it. But if I have you talk me through the problem, then that's a way for me to check to make sure that you know what you're doing and the steps that you did. Alrighty, guys. I will see you at 1 p.m. today, Wednesday, for our little check-in. All right, guys. I hope everyone's doing well. I miss you, and have fun. All right, bye.